Where does this packet go? You have a data packet, which is just a small chunk of your information traveling across the internet, arriving at a router. The router acts like a traffic officer at an intersection, deciding where to send that data next. It looks at a routing table, which is a list that maps destination network addresses to specific physical ports on the device. Think of this as a simple logic rule, where the destination address matches a specific interface or exit point for the signal. Now imagine your router is at the center of a map, with multiple networks branching out like different highways. When your packet arrives, the router picks the correct path, or next hop, to guide the data toward its final destination. Ultimately, a routing table is just a digital roadmap that keeps traffic moving in the right direction. How do packets find the fastest path? Imagine you are at the start of a network of routers trying to send data to the end. You have 3 distinct routes to choose from. Notice how the direct path is red, the top curved path is yellow, and the bottom one is green. Now, imagine traffic jams on the red and yellow paths, which we call high cost. The green path remains clear and low cost. Because you want the quickest delivery, your data highlights the green path and follows it all the way to the end. But how do routers actually decide this? The total path cost is just the sum of all individual link costs. These costs are calculated using bandwidth, which is essentially the speed of the connection. Higher bandwidth means lower cost, making that path more attractive. Watch as the network conditions change in real time. Now, the top path has the highest bandwidth, becoming the new greenest option. Your packet automatically detects this change and shifts its route to travel along the top instead. Ultimately, the route with the lowest cumulative value wins. How does your data find the fastest route across the internet when you click a link? Think of this network as a series of connected points, where your computer is the starting node and the server hosting your content is the destination. Every path between these routers has a weight, which represents the time or cost it takes to send information across that specific cable. When you initiate a request, your computer runs an algorithm that pulses outward, exploring all possible paths simultaneously to see which combination of connections offers the lowest total cost. This mathematical rule constantly compares the path it just discovered against the ones it already knows, always choosing the minimum value to ensure efficiency. As the search completes, it identifies the single, most effective chain of connections from start to finish. Shortest path found.